school?
No, you'll probably get it after school starts.
Oh, yes, yes, yes. Your school is not yet started, but mine is started. Okay. So today we are talking about pressure. This chapter is basically it consists of some topics which have been eliminated last time, and the topic mm, has a variety. One question is there by all means in all exams. At least one question is there from pressure, right? And that question is from 5 to 7 marks. So, what is pressure? So, when we talk about pressure, pressure is actually how much force is being applied per unit area. Okay. So, when we are talking about the pressure, it means that how much force do we apply on a unit area of a body. So, its unit is actually meter sorry, Newton per meter square. Okay. So when I say that pressure is defined as force per unit area, then I have this equation: pressure is equal to force divided by area, and then its equation, its unit becomes Newton per square meter. And when its unit is Newton per square meter, it is basically a scalar quantity, right? So when we talk about pressure, so we have two types of, sorry, three types of pressure: pressure in solids, then pressure in liquids, and then we will talk about pressure in gases. All these three materials have pressure. So I will talk about that pressure in solid first. So in solids, force is usually the force of the weight of the solid, and then area is that which is area of contact of that solid with the ground. So if I say that F is the force and A is the area. Area means this length, and this width. Then basically this pressure will be, if length and width is greater, I mean area is greater, pressure would be decreased if I keep the force constant. So in this case, I have I have a brick, and in that brick is having the weight of 11.1 kilonewton, and it is placed in two positions. Position A is such a way that its base area is 20 times 50. So how much area do we have? 20 times 50 is the area, and 11.1 or 11 100 111 kilopascal means it is actually the total force divided by this area. And then I will put it here. Conversion is important. The only thing is conversion. So when you are going to have conversion, remember this thing, that centimeter will be converted into meter. You know how? Centimeter divided by 100, and you will get it into meter. So you have converted this, and you got that pressure is equal to this much. It is 2.2 kilopascal, right? This is in position B. Sorry, this is in position B, and in position A, I have this much pressure. So in position A, area of contact is increased, not the weight. That's why what happens? Its pressure decreases. So hence, pressure is more if area of contact is smaller. If area is increased, pressure will decrease. Right? Are you getting this thing?
Yes.
Okay. Then we have another concept of pressure of the gas liquid. Pressure of the liquid is basically based on pressure on fluids, right? So all the fluids, they have some pressure, like they have they exert some force on their base where they are being filled. They apply some force on the container or pressure on the container. So when we talk about liquid pressure is due to height of the column. For example, here I have, maybe it would be erased, so it would help you out to get clear understanding. This is what this is a tube, and in that tube I have filled tube A at till this level. And this is having a bore on the both ends. So what will happen? or what happens, it has, the water is getting out of that, but pressure is very small. But if it is filled like this, pressure would be increased. So, pressure depends upon that. In the same way, there is another concept of the pressure, that if I simplify the concept for you, because you are going to appear in exam, then pressure of a liquid depends upon three major things: density, value of G, and yani gravitational field strength, and its height of the column. So these are three parameters which are affecting the pressure. So if I derive an equation of pressure, so pressure is equal to rho g h. If I define the equation of that, I mean, if it is basically to be memory recalled, but that is equals to rho g h. What is equal to that? Rho g h. Rho is density, g is gravitational field strength, and h is height. So remember this thing: whatever the shape of that container is, whatever the shape of the container is, if the vertical height is same, check this one out. All the liquids are have same density, and they have same vertical height. Vertical height, I'm talking about vertical height. So they have same vertical height, that's why pressure on the base of all these containers is same. Okay, is it clear to you?
Yes, sir.
So whatever the shape is, it does not matter. Here I have drawn some diagrams. For example, if a person is there, and that person is having a mean, if it is over here at this point, okay, below the sea level or whatever that is, then this is a swimming pool and this is the sea. Okay, if there are two swimmers at equal depth and density of the water is same for both of them, then it does not matter that whether the swimmer is in the swimming pool or swimmer is in the sea. They will have same or equal pressure on them, because the density, G and height all are same. So when they are same, pressure would become same. So remember this thing: pressure of this was basically related to pressure of the liquid. Here I was talking about that. So here I have mentioned one thing, that those holes which are at deep, for example, this is the hole. This hole is uh, at such a point that the height above this hole is greater, height of liquid column above the hole is greater. That's why what happens, it has largest pressure. Are you getting it?
Yes, sir.
Okay, so simply again, I considered the same point, but simple, we can say that pressure does not depend upon the shape of the container. But what does the pressure do? Pressure depends upon vertical heights, what else, density, and gravitational acceleration. These are three things at which pressure depends upon. Okay, is it clear?
Yes, sir.
Okay, then we have another consideration, that if we want to derive it, okay, let me explain this to you again, because I have written a lot of things on that. It is very simple to understand, that if we have to derive the pressure, pressure is very easy to derive. And here is, yes, okay, for example, if you consider that a column of the water occupying the total volume V, right? Let's say this is the water column, and this column mean this is filled in a container, and its total volume is V, and that has weight W, and I say that, or I believe that W is equals to mg. So what will happen? W is equals to mass into density. So mass is equals to density times volume. Okay, so I have put density times volume, and G is just a substitute over there. Then I know that volume is equal to base times height. So then weight is equal to rho G A H. So actually now weight is equal to rho G H into A, or whatever you want to write. Then it is divided by area because this is force. And if I say that pressure is equal to force divided by area, and force is basically weight divided by area, and it will be rho G A H divided by A will be gone. So rho G H is your equation. Okay.
Okay.
So here, let's talk about atmospheric pressure. That was all about liquid pressure. So remember this thing, there would be some sort of questions asked to you from liquid pressure, and we can handle those questions by having that knowledge. Now let's talk about this one, that is your atmospheric pressure. So what does an atmospheric pressure do? Atmospheric pressure is basically the pressure due to gases. So here, uh, what do you think? What about this person A is having as compared to that of person B? Does it have less pressure or more pressure? This one.
Uh,
Person.
A, less pressure.
Yes, the pressure of the A is less. So because it is at heights. So when we have more altitude, at higher altitude, pressure increases. Sorry, pressure decreases. Okay, you got it?
Yes.
Yes. So when we say that at when altitude increases, pressure decreases because less at molecules are there. Here, the density of the gas is more. When density of the gas is more, actually what happens? Then more collision takes place, and due to that, more pressure appears on the molecules or appears in the gas container or molecules. So simply speaking, when we say that there would be high density of the fluid, or there would be more molecules, then pressure will be more, and at height pressure will be less. So this is all about in this slide. Then we have the concept of pressure of barometer and manometer that has been excluded from the topic, from the syllabus right now. Okay, that how does a barometer and how does a manometer work, but it can be simply considered as this is a barometer which is basically used to measure the pressure, atmospheric pressure. So when we talk about the atmospheric pressure is simply, let's say let me make you clear. This is the test tube. It is inverted um, in a mercury column or mercury dish. So atmosphere wants to insert this mercury inside this tube. Actually atmospheric is pressing it down, and the height of this, it is trying to push it down. So both of them are balanced. Both of them are balanced, or you can say both of them are in equilibrium. So when they are in equilibrium, I can say that at this position, pressure of this liquid, which is exerted in the downward direction, is equal to the pressure of the atmospheric in the upward direction. That's why we say that pressure due to mercury column is equal to pressure due to atmospheric pressure. So this is basically that concept which tells us that how can we find out the pressure. So pressure of the air is equal to pressure of that liquid, or we can say pressure of the liquid in the barometer. So there is a unit of barometer pressure which is called as uh, of Hg, millimeter of Hg. So I can say that if I put some liquid inside, sorry, some mercury inside, mercury in that uh, in the column here, mercury is placed. So after 76 centimeter, this is 76 centimeter, 76 centimeter, mercury will become stable. Mercury will become stable. Okay. So when mercury is going to be stable, it means 76 centimeter of mercury or 760 millimeter of mercury is creating a pressure which is equals to the atmospheric pressure at the sea level, which is equal to 101300 pascal, which is equal to 101 300 Pascal. Okay, is it clear?
Yes, sir.
Okay, then we can talk about that the glass tube lifted up slightly from dish, and then it is lowered further, and the diameter of the glass is increased or decreased, then glass tube is tilted, and quantity of the mercury in the dish increases or decreases. These all are the conditions which basically, check this one out. One, two, three, four, five. These all are the five different situations in which I told you that whether the pressure would be great or less. So I told you that pressure only depends upon vertical height of the column. Okay, will it be clear to you?
Yes, sir.
Okay, so for example, if I consider different points, this is point A, this is point B, this is point C. So because that is at the top, so pressure is very less, pressure is increased, pressure is more. So as we go deep down, pressure increases. Okay, so there would be some sort of calculations, and then we have to have some um concept about the gas pressure. Similarly, we can say that when we have to consider, oh yes, when we are going to have the pressure measurements, we use another instrument which is called your uh, manometer. What do we call it? That is your
Better.
manometer. Okay, manometer is just a U-shaped tube, this one, and it is very simple to understand that from this level to this level, because mercury's are liquid is same in both columns, only this height is making a difference of pressure, right? Which height is making difference of pressure? Only that height is making a difference of pressure. That's why pressure of this liquid is called pressure of the liquid, and this is equal to pressure of the gas. So if the gas is applying more pressure, then liquid would raised up and over here, and if the pressure of the gas is decreased, liquid pressure would be raised down with this column. So remember this thing, if when the manometer is not connected with the gas supply, its both ends are having equal column, because on both ends atmospheric pressure is there, and that atmospheric pressure is same for both sides. But if we connect this with the gas, then the gas will pull the other side up. Okay, in this way. So you are going to exert pressure from here, so the liquid column will be increased in that side. So this is what I have explained this all over here. So when we talk about what is the pressure of the gas, so pressure of the gas is atmospheric pressure plus pressure of the mercury or pressure of the liquid. How? Check this one out. If you are going to blowing in from this side, then you are going to lift, or you are going to tolerate the pressure of these two segments. One, pressure of this liquid, and second, pressure of the atmosphere. So if we are going to have pressure of the liquid and pressure of the atmosphere both to hold, then gas pressure will be equal to pressure of the atmosphere plus pressure of liquid. So remember this thing. This is the pressure measurements for manometer. If the gas is having less pressure, then left side would be raised up and right side would be decreased, and you will say that pressure of the atmosphere is equal to gas pressure plus liquid pressure. Now there are so many other applications which have been basically disclosed. This has been excluded. This is the application of your liquid pressure. It is application area which is hydraulic press, car lifting, and then we have, yes, this pressure brakes. They all have been excluded from the topic. They are not anymore in the syllabus. Okay.
Okay.
So remember one more thing, that when we talk about the pressure of the gases, it is very simple to understand that if we have pressure in the gas, so gases have volume and pressure, volume, pressure, and temperature, they all are the properties of the gas. So volume of the gas is inversely proportional to its pressure. So if I say that P1 V1 is the pressure of and volume of condition number one, and P2 V2 is the pressure and volume condition in state two, then in both these states pressure and volume remain same. So if I say pressure 1 v1 P1 V1 equals to P2 V2, so in this case you can calculate different questions, or you can calculate different quantities for the pressure of the gas. Okay,
Okay.
is it clear? So this is all about the pressure. Pressure is not a big topic anymore, so I hope that it would be understandable, or it is clear to you. Do you have any question to be asked in this one? Yeah.
Now.